Ladies and gentlemen, my name is Toms Pastars, and I want you to imagine yourselves on a cruise ship, having the time of your lives, drinking a cocktail with your friends, and all of a sudden the cruise ship starts sinking. So naturally, you run with your cocktail to the lifeboat, where you find out that the modern lifeboat only keeps contact with the ground for 48 hours. So in other words, if the authorities do not find you in 48 hours, you're all alone in the ocean, completely lost with your cocktail. This is a very serious power supply issue and can be solved with our modern technology. So this is a brand new technology that converts wind power to electricity. Here's how it works. So our design has three main components. There are two metal surfaces connected with each other and then secured with a metal rod. How are the two metal surfaces connected, you might ask? Well, they are connected with a special material, a piezoelectric film. This material has special properties, mainly that when it is bent or deformed, it produces electricity. Right. And here is our design, our first prototype in action. As you can see, as the wind is blowing, the two metal surfaces flop up and down, bending the piezoelectric material and therefore generating electricity. As you can see, even in very, very strong wind conditions, our model works perfectly well. Right. So why is this such a groundbreaking innovation? Well, this innovation is so groundbreaking because it would ensure cheaper and greener energy delivery to IoT devices. What are IoT devices, you might ask? Well, IoT, or Internet of Things, are small devices like sensors, trackers, and so forth that collect a lot of data about our everyday lives. They are an integral part of our society, and we couldn't function without them. That is also why the IoT industry is absolutely huge. In 2024, the IoT industry's total revenue was almost $400 billion US, and it is expected to be a $1 trillion industry by the year 2034. Right. So I'm sorry, I don't know why it's all messed up. But so who would be interested in our product? Well, anyone who really needs to measure something, communicate something, or track any data outdoors. Right. So currently, this is achieved through primary batteries or solar panels. However, WindWise would be a technology that could supplement these two energy sources and function in instances where these two solutions are not as effective. Right, so this technology has multiple applications. For example, agriculture. The modern day farmer employs a dozen of IoT systems, all designed to monitor stuff like soil condition, air temperature, air humidity, and so forth. All of this could be powered by WindWise. The current system that the farmers use is extremely inefficient because when the primary battery dies, they all have to be replaced. And you can imagine, as the farmer who has about 10 of these devices per 1 hectare and has hundreds of hectares, imagine just the hustle that the farmers have to go through just to replace each battery. WindWise would eliminate this problem completely. WindWise has also many weather monitoring applications. For example, WindWise could power the sensors in weather stations and weather balloons, right? These stations are specifically designed to collect data about stuff like air humidity, air temperatures, and so forth. WindWise could also power the sensors in water buoys, and they could power the devices that hikers and mountain climbers use in conditions where the wind is extremely strong, but the sunlight is not so available. But what's most exciting is that this WindWise technology could power entire cities, entire infrastructures, right? For example, automatic lighting and so forth. WindWise could also have many space applications. For example, as we all know, in the next following decades, we're planning on conquering Mars, and so WindWise could be used to power some IoT devices on Mars. Right. So you might have a question. So why choose us? Why not some alternatives like primary batteries or solar panels? Well, when we look at primary batteries, WindWise technology lasts significantly longer. We have calculated that WindWise technology would last for about 10 years before it needs replacement, and with primary batteries, you could squeeze out at most maybe 2 years. We are also way greener than primary batteries. We leave no carbon footprint behind, whereas primary batteries, they tend to have significant. So what about solar panels, right? So solar panels, we are significantly cheaper than them. Yep. Raise your tone. Oh, sorry. That's our team. And then there are like the slide. What's next? And what's next is acquire funding, acquire patent specification, and finalize products. And yeah, well, that's it. Thank you so much. Okay, this will be the best 30 seconds of your entire life. Right. So we are way easier to own than solar panels because we do not require any panel cleaning. While you may have to clean your panels every once a year, WindWise requires no such maintenance. Our team consists of 3 members. We are all high school students that are highly motivated, and we're studying physics at the best public high schools in Latvia, and we're studying it at an advanced level. So what's next? So the first step would be to acquire more funding. With that, we could do more testing for longer periods of time. We could improve the design or even change it because we're open to new ideas. We could also acquire a patent specification. This would give us exclusive rights. Next, we could finalize the product, and then we could conquer the IoT market by releasing it. Thank you. Yeah, go ahead.
Hey, me again. So I wanted to ask, what's the benefit between your solution and the wind generators? Because they already exist. So it's already a known wind generators, right? They put them on sailboats already, right? They use them on farming lands as well. So I wanted to ask, what's the...
Well, first of all, it is kind of hard to scale down a wind generator, right? I mean, to the level that it needs to be scaled down to power some IoT devices. You'd imagine that this is much more compatible with IoT devices, and it's much more easier to manage because it's much more, well, smaller in scale. Right, and one other thing, as I mentioned before, this is not meant to replace solar panels or other kinds of wind harvesters. This is just supplemental technology that could be used in some instances where this solution is more effective than others, essentially, right? And as I mentioned, because of the piezoelectric material, it is very cheap to produce. This is very cheap. Really, the most expensive component of this entire design is the piezoelectric film, right? And suppose that we buy, all the materials in big enough quantities, right? We could lower the cost significantly, right? So the prototype that we have built currently, well, we built it for, I think, like 10, everything in total was 12 euros, right? And if you buy it in bulk, we can make it very, very cheap. And so that would be the benefit, as the other wind generators that you mentioned, right? They require all kinds of, motors and stuff like that, and like the thing that converts, the wind energy into electricity. However, this one, right, the piezoelectric film, right, it in itself it generates the electricity. So that's like essentially the benefit.
But still, another question that remains regarding durability, because based on my experience, what I already know is that the more moving parts you actually have, every single material has a limit of how many times it can be bent, right? So this piezoelectric film will still eventually break. So the question is, how come you say it's no maintenance?
Well, it's no maintenance in the sense that you do not have to maintain it for it to work, right? As I mentioned in the slide previously, right, the piezoelectric material, it loses its qualities after a certain time. And that time is about 10 years, right? That's when it becomes so ineffective that you might want to replace it, right? However, what I do think is very important to mention is the fact that there have been previously 1 degree of freedom similar designs to this, right? And they have tested those designs pretty rigorously, and they have found out that they can do more than millions of these flapping motions, right? And they work just perfectly fine. Sorry?
It's not that much if you're talking about the wind.
Yeah, no. Well, like I said, they have rated it to no, not saying a million, right? I'm saying millions of. So that's something very specific and very important to underscore, right? And so yeah, like I said, they have been rated previous designs with 1 degree of freedom, meaning that there are not there's no second flap that moves, right? They have been rated that they can last 10 years without any decrease in efficiency, right? So I wouldn't worry too much about that, but that's a very legitimate concern. Thank you.
Sorry. One more question still remains. Then let's say you are lost in Mediterranean and not in Baltic Sea, so it's less windy. So in this scenario, but like wind doesn't just come up, it's pretty still. There are people lost in the sea because they have sailboats that use how do you call these? Like no, the thing that catches wind. That lets you go. A sail. That's why it's a sailboat. Sorry, guys. Yeah, so there are people that get stuck there because there's no wind for days. So you would still lose connection then and lose electricity, right?
Well, no, not really, because so this wind harvester, right, it harvests power that is then stored in like a battery, like a reusable battery, right? So that because the wind harvester isn't working at the moment, that doesn't mean that the battery does not have power to actually, power the GPS device, right? So. Yeah. That's actually that's a funny idea. We tried it with our friends. If you blow it, you can't really generate enough, wind to move it significantly. But yeah, you can try bending it with your hands. So yeah.
Or you can glue photovoltaic cell on this flap, and you don't need to wave it. Okay, the question is, what is the cut-in speed?
Sorry?
Cut-in speed, wind speed.
Wind speed?
Yes, cut-in when it starts generating electricity. 1 meter per second, 2, 3 meters, 5, 7.
Well, as we saw...
Yeah.
Sorry. As we saw in the presentation, it was already moving at a very rapid pace. Sorry? Yeah, okay. Oh, yeah, that's a great point. So I will show you, as we already saw in the video. Yeah, at 4.5 meters per second, it was already very rapidly flapping. So.
What is the cut-in speed?
Well, I do not know the specific number, right? And I suppose that if we acquired some more funding, we could find out. Well, yeah, but that's true. Sorry, maybe we can see. Right, so just for a little review, we can already see that at 4.5, it's already moving very strongly, right? But how about, I get back at you in a week or so and I'll tell you the cutoff speed.
Okay, good.
Yeah? Okay.
In a week?
In a week.
Okay, I'm waiting for email.
Yeah, just one more question regarding this video. Actually, when was the test done? Was it actually done during the hackathon?
No.
Okay, never mind then.
Okay, thank you very much, team. Thank you.